Hello everyone. So welcome to Discrete Mathematical Structure, Module-2, Session-8. So in this session, as I discussed in the previous session, let us look into the examples or some example of combination, because in the previous session, I had introduced you what is combination, and I just gave you the comparison between permutation and combination, and I just told you these are the forms of permutation, where we are going to say as n factorial divided by n minus r factorial, and combination is going to be n factorial divided by n minus r factorial into r factorial. And this form was derived because whenever I am going to say it as permutation, so the permutation is going to be all about picking r objects out of n objects, and I am going to arrange this. There are two phases or two tasks which I need to complete whenever I'm going to talk about a permutation. Pick r objects, then think about arrangement over here. But whereas in combination, my job is just to pick the objects, and I'm just going to look into this, and I'm just going to see whether the arrangements are required or not. Fine. So now whenever we are going to have such forms, so what exactly we are going to think about? Whether now I need to think about a permutation or should I think about a combination? This is the one big scenario which I had discussed with you in the last session. I had left you at 3 points which I told you I'll be carrying forward in the next session. The very first point was I just gave you a scenario of cracking a locker with the 4-digit code. And the second thing is, I'm just going to tell you what are the different cases with respect to combination. And along with that, I told you I'm going to pick up some examples and I'm going to make you more familiar with combination. So let me take one by one now. Fine. The very first, the scenario which I just gave you and give a thought about it. That is, I'm going to have a locker which requires 4-digit key to open the locker, and I need to crack this because I don't know what is the code for any reason. I don't know what is the code, but I'm sure that this 4-digit, what is going to take? It's going to be out of 0 to 9. That is the 10 digits which is available with me now. Hence, I'm going to have 0 to 9. I'm going to have the digits from 0 to 9, which makes me 10 digits, and so I'm going to say n equals 10. Fine. And I'm going to have, I just want to pick 4 digits. I need to know what I should fill here, and I'm going to know what I should fill here, and I'm going to think what I'm going to fill here. So now what exactly I'm going to do here? There are 10 objects, and out of those 10 objects, I need to pick 4 objects. And I need to fill this. So now, should I think about combination now or should I think about permutation? This is the biggest confusion right now. What I'm going to have, what most of you people are going to have. So now let me just give a hint over here. If the hint is something like this, it is going to be clear enough for me that should I use permutation or should I use combination. If there is no such hint, simply I will go with permutation, because combination is part of permutation, picking the r objects from available 10 objects. Hence, directly I can go to permutation. But going to permutation, which is a large number of ways compared to combination, which going to take a large amount of time to crack the code. So in that sense, I should be smart enough and I should think about whether should I use combination or should I use permutation. So permutation is going to solve the problem. It's going to solve the problem. The only reason why again I'm thinking about combination is just to see that whether I can reduce the number of ways or not. That's the only important point what we need to note it down here. Fine. So now the hint what I've got here is, when I'm going to pick the digits, whenever I'm going to pick the digits, I'm going to use any 4 digits in any order. The locker is going to open. That is, if I'm going to pick the digits as, 0, 4, 5, 6. This is the key what I have been given for the locker key, which I don't know at this point of time, but I want to try what is this going to be. So when I say I need to use this 4 digits, if I use this 4 digits, the locker will open. And so now what I do? So now I'm not giving any order here. I'm not going to give any order. So 0, 4, 5, 6 I can give, the locker will open. Or even if I'm going to give 5, 4, 0, 6, the locker will open, because again it's combination of the same 4 digits. Again, if I'm going to use 6, 0, 4, 5, the locker will open. So if I give any combination, the locker will open. And so now what I should do? I just need to pick the 4 digits from the n objects, which is going to make up my locker without thinking about order. If I add this hint, if I know that this is what the locker key is made about, the locker security is made about, then straight away I will go and think about combination, because order is not important for me right now. But if this hint was not available, and if the hint was again that the key should be in this order only. The key should be in the same order only. If the order is so much important enough, and if it really matters, then think about permutation, because I need to go ahead and look at the array, all the sort of arrangements, all the way of arrangements of the 4 objects what I am going to pick. Now this is how I am going to make use of the situation, whether this should be applied in the being in the context of permutation or being in the context of combination. So now you are clear with this, and you know what is n, you know what is r. If you think you need permutation, use this form, and if you think it is going to be combination, use this form. And this is one point which I wanted to make you clear about. So now let me take the second point where I had left with you. And the second point what I wanted to discuss with you in relation with combination was the 3 cases. So let me tell you what are those 3 cases. Now in the case 1, that is whenever the value of n is going to be r, and what if the value of r is going to be n minus r. So now whenever I'm going to try to find n comma r I'm going to try to find whenever I'm going to have c of n comma, in the place of r, what if I'm going to have n minus 1, that is what if I want to pick out of 10 objects, what if I want to pick 9 objects, or if there are going to be 5 objects. So what is the form I'm going to use to pick the 4 objects. So this is how I'm going to think about it. And in that case, so now in both the cases, so anyhow I know what is the first case for n comma r, the form which I already know. And now just try to find what the form for this is going to be. If I'm going to have n minus 1, r is n minus 1, and this is going to be r is this remains same, and this is n minus of n minus 1. So let me write it down here. For this I'm going to write this as n factorial, and in the place of n it is n, in the place of r this is going to be n minus 1 to the whole of factorial, and in the place of r again n minus 1 factorial. Now if I am going to solve this, I am going to end with n factorial, and so n minus of minus n minus n and plus 1. So this is going to be 1 factorial, and so n minus of n minus 1 becomes, so n, I am going to have n as it is, and minus n plus 1 factorial into n minus 1 factorial. Fine. So now n gets cancelled. I am going to have 1 factorial, and I am going to end with n minus 1 factorial. So this is what I am going to have if I am going to have n minus 1. So now what in case? So let me change the case over here, and I am going to say this as r. Let me keep this as r right now. What if it's going to be n minus r, where I am going to have n objects. Out of n objects I have been removed the r objects already. Now what is the combination is going to be? In that case I am going to replace this with r, multiply this with r, and this is going to be plus r, and this is going to be n minus r. So n gets cancelled. I am going to have r factorial into n minus r factorial. The same form I am going to get. Fine. The same form I am going to. I'll just take n minus 1 in the later case. But for this case, I am going to see that case 1 is going to be n comma r and n comma n minus r. So now both is going to be of same form. For the case 1, this is going to be the same form. Hence, there is no change in this. So now we'll just take the next case now. In the next case, what if the value of r is going to be, whenever the value of r is going to be 0, or what if the value of r is going to be n? Fine. What if the r value is 0 and what the r value is equivalent to the number of objects what I want to pick. So you can just substitute and check it out. So when I'm going to have r equals 0, when r is 0, this remains same. So n minus 0 is n factorial into 0 factorial is same, it's 1. Hence I'm going to have n factorial divided by, let me write it over here. So n factorial divided by n minus 0 is n factorial into r factorial is 0 factorial, which is going to be 1. Hence I am going to end with n factorial by n factorial is 1. I am going to end with 1. There is only one way. Whenever the value of r is going to be 0, I am going to only one way of dealing this. Fine. So now what if r value is going to be equivalent to n? So I am going to have n factorial. N minus n is 0 factorial into n factorial. I am going to end with the same condition again. Again I am going to end with 1. So whenever I am going to have certain value of r equals 0 and r equals n, that is whenever I am going to have c of n comma 0, which is equivalent to, so c of n comma n and is equivalent to 1. So special case which you can remember. In the similar way I can relate this as this is equivalent to the form what I have it already known. Fine. So now we'll just move on to the case 3. So in the case 3, what if the r value is 1 and what the r value is n minus 1? So which I have just taken as a case 1. Then now I am taking this as r equals n minus 1. So in this case, what happens? So now if r is going to be 1, n factorial divided by n minus 1, that is n factorial divided by n minus 1 factorial into 1 factorial. So 1 factorial is 1 and I remain with n minus 1 factorial, and I am going to end with, I am going to have n minus 1 factorial into 1. So n factorial into n minus 1 factorial. So now can I expand this as n into n minus 1 factorial whole thing divided by n minus 1 factorial? Can I do this? Can I do this? Because this 1 factorial into 1, hence I have just expanded this. If I am going to cancel this 2, I am going to end with n. So whenever r is going to be equivalent to 1, directly I can say it is going to be 1. Similarly, if I am going to have r equals n minus 1, n minus 1, so n gets cancelled, I remain with 1 factorial into r is equal to n minus 1 factorial, and n factorial divided by n minus 1 factorial is represented as n. Again I am going to end with the same case. Hence in the case 3, we are going to have c of r comma or c of n comma 1, in the place of r it's 1, is equivalent to c of n comma n minus 1, which is equivalent to n. Hence, so remember these 3 cases, the case 1, the case 2 and the case 3. So this is what you need to remember. So these are special cases which I can directly use. It is 1 when I know the value of r is 0, or when I know what is the value of r is going to be equivalent to n, and when I am going to have the value of n as 1 or n minus 1, I know what is now, it's going to be n. In any other case, you need to use the general available form. So this is what I wanted you to discuss about the 3 cases with respect to combination. Hence, now let me take the third point. This I told you that I'm going to discuss few examples with respect to the combination. So let us do that. Now just let us take an example as I told you. So now just imagine in my class or in the room where I am in, I got 12 students. And I need to form a group. Of 5 students. Fine. So I am just going to have 12 students. Add 12 students. And from this 12 students, I need to make a group of 5 students. Fine. It is not n number of groups. Don't imagine like I am going to make a 5 and 5 and I remain with 2. It's not like that. I just need one group and the group should consist of 5 students. Fine. So in this case, now do you think about permutation or do you think about combination? Because again I am going to have n objects, which is going to be n equals 12, and I am going to I need to choose 5 students, which is going to be r equals 5. So now, do you think about permutation or do you think about combination? This is the trick again over here. So now see, the 5 students what I am picking now, the 5 students which I already picked, the student 1, 2, 3, 4 and 5. The 5 students which have been picked, should I think about ordering them? For example, if I pick the first student and I say he is going to be the student 1, and if its position is fixed, I am going to pick the second student. Again, the second position is fixed. If the positions are fixed and if the order are so relevant to me, think about permutation. If the order is relevant to me. If the order is not relevant, I can pick the student 1 and I can place him at the 4th position. I can pick the student 2, I can place him at the position 3, and even if I want, I can shuffle. The order doesn't matter to me. So now where does this order matters to me and when the order doesn't matters to me? For example, there are 5 ranks. Which I need to allot for the students based upon their performance or based upon some criteria. I need to allot ranks for the students. Hence, I am going to say rank 1, the rank 1, student 1. Position is fixed. I cannot say this student can be rank 1, the student can be rank 3 or rank 5. The student which I am going to pick now, he should be always in the rank 1. Hence, the order matters now. Now I should say who is at the rank 1, who is at the rank 2, who is at the rank 3, rank 4, rank 5. Order matters. Now think about permutation. Now in the given scenario right now, the scenario what I am taking is, and I don't have any such positions. Randomly, any 5 students I am going to pick as a group. And the order doesn't matter now for me because I have not given any positions right now. Hence in this case, I think about combination. So this is how I am going to use the trick to solve a given scenario, to use a permutation or should I use a combination. Hence, I am picking 5 students because I am not giving any positions, because in the previous examples while discussing with respect to permutation, I was giving positions. That is, I was giving something like I am going to have a number plate. If I am going to talk about a number plate, I am going to say the first 2 digits is going to be odd or the next 4 digits is going to be even. Something like this, the position was fixed. Hence, I was talking about permutation in that cases. But now the position, there is no any positions or any allocation or a vacant place which I need to start filling over there. Hence, in that case, I need not think about the permutation right now. Hence, I'll go and solve this problem using combination. Until unless they don't give you the position and the criteria to select, don't think about permutation because this is a step ahead of combination. And so now if I am going to talk about combination, next in that case I am going to have C and the value of n is 12 and the value of r is going to be 5. Substitute this, n is going to be 12 factorial divided by n minus r, that is 12 minus 5 factorial multiplied with 5 factorial. So find, so this is going to be the number of ways in which I can choose 5 students out of 12 students to form a group of 5. So this is how I am going to use the combination to solve such problem. So let me just give a small variation in this and check it out whether this is going to work or not. Fine. The small variation of what I am going to choose here is, I am going to pick a student, I am going to pick one student, and I am going to say E is going to be leader of the group. Fine. The first student which I am going to choose, I am going to say as E is going to be the leader of the group. So now, how many options I have got? How many ways I have got in doing this? That is, if I am going to take the next case, let me take the next case now, where I am going to pick a student from the 12 students as a group. How many ways I can pick? I can pick the first student, second, third, and all the 12 options are open for me. I can pick any student out of those 12 to make as group leader. Hence, I am going to think about now permutation or think about combination, because I want to pick only one student now. Let me stick it to combination, and I am going to say n is going to be 12 and r is going to be 1 at this point of time. And so what is Cn comma 1? The case what we just discussed. Whenever I am going to have n comma 1, I am going to have n. I am going to have n. That is, there are n number of ways. So whenever we are going to have C of n comma 1, that is r is 1, and let me say it as 12, or let me say it as n comma 1. So which I have just discussed with the cases. Whenever C of n comma 1 is going to be, it is going to be n. I am going to have it as n. Hence, so C of 12 comma 1 is going to be 12. I am going to have 12 ways. I am going to have 12 ways. So now when I am going to have 12 ways, now this is the half of my solution, because I have just picked only the group leader. Now I am yet to complete the group. So the group was supposed to consist of 5 students. Out of 5 students, one I made as a group leader. My part of job is done. So remaining is, I need to pick 4 students. I need to pick 4 students to fill the group. And out of how many students? Now it's going to be 11 students, because out of 12 already one I have made him as a group member, and I have made him as a group leader already. Hence, I am just going to have n equals, I am going to have n equals 11, and I am going to have r equals 4, and I am going to have combination of 11 comma 4, which is equivalent to 11 factorial divided by 11 minus 4 factorial into 4 factorial. Fine. So now this and this job should be done at a time. Hence I need to use the product rule. Hence the final form will be 12 into 11 factorial divided by 11 minus 4 factorial into 4 factorial. So this is, and solve this, and it is going to be the number of ways. This is the way how I am going to solve this. So now let me take one more variation now. Let me take one more variation, the same problem. Fine. And the next variation, what we can have in the same problem is, so now I am going to have 12 students. Out of these 12 students, let me say that there is going to be 7 boys. Yes, I am going to have 7 boys. Plus I am going to have 5 girls. In total, again I am going to have n equals 12 itself. I am going to have this way, the 12 students. Now I need to pick 5 students as a group, and I need to make sure the condition is when I am picking 5 students, out of these 5 students, what I am going to pick. So there should be at least one boy or one girl. At least all the 4 or all the 5 can be girl. or all the 5 can be boy. That's not the case now, because there can be 4 boys and 1 girl, and there can be 4 girls and 1 boy in any combination, or there can be 2 boys, 3 girls, 3 boys, 2 girls, any combination, but I need to make sure the group at least contains 1 boy and 1 girl. So in this case, what exactly I am going to do? So now first, I know that if I am going to pick 5 students to form a group, I am going to have C of 12, 5. That is, I am going to pick 5 students. So this is when I complete this form, when I find what is the combination of 12, 5, what I am going to end with? I am going to have all the ways. I am going to have all the ways of picking 5 students into the group, where this group is whatever I have been find it. This involves even such scenarios where all the 5 are boys, which should not be the case, and all the 5 are girls, which again should not be the case. Now what I should do? I need to remove all the ways where only boys are in the group from this lot, and I need to remove all the ways where only girls are in the group. If I remove this 2 criteria or 2 ways from this, then I would have the number of ways where I have at least 1 girl or 1 boy in the group. Fine. So to do this, I need to find how many ways are there if I am going to pick only boys. How many ways are there? Now just consider only the boys now. If I just consider only the boys, then I am going to have n equals 7, and the group size is still 5 because the group consists of only boys now. Hence I am going to have r equals 5, and to find number of ways I am going to use the combination again. So C of 7, 5. So now similar way, if I am going to talk about girls, if my focus is only picking girls, in that case I am going to have n equals 5 and r equals 5. Hence we are going to have C of 5, 5. Now what is C of 5, 5? I did not tell you. It is going to be a special case. You can use the form directly, but at the end. So now this is the total number of ways where I can form a group of 5 from all the 12 students, which also includes all the boys and all the girls. And this is only the group which includes only the boys, and this number of ways includes only the girls being in the group. So now what I should do? I need to subtract this 2, and so minus, so C of 7, 5 minus C of 5, 5. If I find the solution for this, applying the combination formula, I know how many ways I am going to have, where I am going to form 5 students group, where at least I am going to have 1 boy or 1 girl, and I am going to, out of the 2 students, what I am going to have. So we are going to analyze the problem and apply the combination as and when required. Fine. So we will just pick one more example now. And now just look at this example, where in this example, it's a scenario where you imagine you are attending an exam, and the question paper pattern is something like this. Fine. In the question paper pattern, you have got part A and part B. You have got the question paper with part A, and you are going to have part B. And in each part, I am going to have 4 questions. This I am going to have question 1, I am going to have question 2, I am going to have question 3, I am going to have question 4. Similarly, even in part B, I have got 4 questions. So question 1, question 2, question 3 and question 4. So now a student or you need to answer 5 questions now. Out of available 8 questions, you need to attend 5 questions. You need to attend 5 questions. So now how many ways you have got? Your order doesn't matter again, because nowhere I am saying you need to attend the question 1 first, question 2 first, question 3 first. Now you are free enough to answer any question picking it as a first question or second question and so on. Hence, when the order is not so important, what do you ultimately do? You're going to think about combination. So now at this point, if you want to pick 5 questions and you need to answer, how many ways you have got? You have got the value of n is 8, because totally there are 8 questions and you need to answer 5 questions. Hence, you are going to solve it using combination as C of 8, 5. So find the solution, what I am going to end with, and this is the number of ways. Fine. If there is no any conditions, if there is no any parameters, criteria, this is what I am going to do. But now let me put some sort of condition here. And the part A and part, the reason the question paper at part A and part B, because, so now when you're going to answer 5 questions, you need to make sure you answer at least 2 questions from any one part. Remember this. Now you are not free enough to pick any 5 questions of your choice out of this 8. You need to pick at least 2 from part A. If I pick at least 2 from part A, I need to answer 3 from part B. If I pick at least 2 from part B, I need to answer 3 from part A. There are 2 ways which I can think now. I am going to give a thought in 2 ways. Whether should I pick 3 from A and 2 from B, or should I pick 3 from B and 2 from A? I got 2 ways of dealing this now. Hence, both the way I need to concentrate and I need to think about this. Fine. So now, in that case, so let me write this as 5 questions over here for your reference. Fine. And now the case 1. In the case 1, where I am going to say that, so from part A, I am going to say 3 questions. That is 3 questions from part A, or it as part A, and 2 questions. Let me write over here. So 2 questions from part B. Fine. So now in this case, what I am going to do, I will take this next case later, but what exactly I am going to do here? So now I am going to have 3 questions here. Hence, out of 4, I need to attend 3 questions here. Hence, in this case, the value of n is 4 and the value of r is 3. And in this case, the value of n is going to be, value of n is 4, because the part B contains 4 questions. Out of 4, I need to pick 2 questions, and r is 2. Hence, I am going to have this as C of 4, 3, because order doesn't matter to me, and multiplied with this way, that is C of 4, 2. So find, and this is going to be your answer. And the reason why I am using multiplication here, because I need to do both the jobs at the same time, hence I am using product rule. Fine. So now just look at the case 2. If you just look at the case 2, in the case 2, 2 questions from part A and 3 questions from part B. Hence n equals 4, r equals 2, n equals 4, r equals 3. I need not elaborate why I am doing this. Hence, I hope you understood, and directly I can say this as C of 4, 2 for part A multiplied with C of 4, 3 for part B. You are going to find this. So now this is the number of ways when you are going to think in the first case, and this is the number of ways when you think in the second case. So now ultimate solution is going to be, so I was supposed to find how many ways, in total how many ways are there. In that case, I need to add whatever the value I am going to get from the case 1, that is C1, and whatever I am going to get from C2, I need to add this both, and the final solution is C1 plus C2, and I am using product rule. Sorry, I am using sum rule here, because both the tasks, case 1 and case 2, need not done at the same time. I do it either case 1 or I am going to do case 1. I choose 3 and 2, or I am going to choose 2 and 3. That is what I'm going to use R, hence I'm going to use the sum rule. This is going to be the final number of ways what I'm going to have in this case. Fine. So now this is where I'm going to have part A, part B question. So now what if I'm going to have part C? What if I'm going to have part C? For example, what if I'm going to have part C, where I'm going to have 5 questions in part A, and I'm going to have 6 questions. I'm going to have 6 questions in part B, and I'm going to have 4 questions in part C, and you need to answer 7 questions. You need to add 7 questions, at least 2 from each part. So now if you think about this particular problem, how do you solve? This is something similar to just the problem what I solved right now. Fine, that is at least 2 from each part. Hence now you have got how many ways? You have got 3 ways where you can think about this. You have got 3 ways. Fine. The very first way is, that is, let me say it as case 1. In the case 1, if I'm going to answer 2 from part B and 2 from part C, I need to answer, so remaining is, so 2 plus 2 is 4, remaining is 3 questions. I need to answer 3 questions from part A. Hence I'm going to add, so 3, 2, 2, the case 1, and in the case 2, I'm going to pick 2 questions from part A, 3 from part B, and 2 from part C. And in the case 3, I'm going to have, so 2 from part A, 2 from part B, and 3 from part C. So now on all these cases, the value of n is going to be same. That is, so 5 plus 6, so it's going to be 5. Hence, I'm going to have this as R, and I'm going to have n as 5 here. So multiply this with R equals 2 and n equals 5. N equals 6 because this is part A, part B which has got 6, and part C has got 4, n equals 4, and R equals 2. Is it fine? So now if I'm going to apply combination as C of 5, 3, C of 6, 2, C of 4, 2, I'm going to find C1. Similarly, this is R, and this is R. Everything should be multiplied, and then I know what is n equals 5, n equals 6, and n equals 5. So find what is C2. Similarly, I am going to find this for C3, and if I add all this, I am going to find what are the number of ways I am going to have. So this is what exactly I am going to address the problem whenever it is given scenario of question paper. Fine. So let me take one more example and try to use solution for it. In this next example, so let me take a situation. Where you are going to have, 11 close friends. Fine. You have 11 close friends. It is 11. Let me just put it as friends. You have got 11 close friends or 11 friends, and you are organizing a birthday party. And you need to invite 5, you need to invite only 5 for the birthday party, because your parent has put a restriction that for your birthday party you can invite any 5, not more than 5. You need to invite any 5 for the birthday party. And now you have got all the 11 friends are close to you, and so now you can pick any 5. You are free enough to pick any 5, and you can call for the birthday party. And how many ways you have got? That is, you have got 11 friends, and you need to invite any 5. In this case, you know what is n equals 11 and R equals 5. Order doesn't matter, hence I am going to use the combination, and I am going to say C of 11, 5. This is how I am going to think. Now there was no restriction of picking 5. Right? The only restriction was you are supposed to invite any 5 out of your 11 friends. Now let me put a restriction here. There is a condition which I have forgotten. That is, there are two friends. Among those 11 friends, there are two persons where if I am going to invite anyone, if I am going to invite one friend, the other friend will also attend, because those two persons are close enough that they will not attend any party separately. If anyone attends, the other also attends. If the other doesn't attend, the second one also doesn't attend. There are such two persons out of my 11 friends. So now, in this case, what I am going to do? I am going to have two cases over here. The very first case is, so this was no restriction. The second case, I have got two persons out of this 11. So two persons out of this 11 who will not attend separately. Will not attend separately. So hence, so now if I am going to invite the person 1, something like I am going to say as P1 and P2, and from P3 to P11, I don't have any problem with this people, but only this two. So if they attend, they will attend together. If they don't attend, if anyone doesn't attend, the other will not attend. If anyone attends, the other will also attend. So if I take the first case where I am not inviting the P1, automatically the P1, 2 will not attend. Hence he will be out of my choice. Hence how many remain choice? Because I am not inviting P1, it's out of my choice. Hence P2 will automatically be out of my choice, and remaining are 9 friends. I need to invite 5 out of this 9 friends. Hence I am going to have n equals now, I am going to have 9, and R is going to be 5, because I need to invite 5 friends. Hence I am going to have this as C of 9, 5. Now with this I am going to have 9, 5. Fine, this is fine. So now with this, now if I am going to invite P1, so P2 will also attend. If I am going to invite P2, P1 will also attend. Hence, so this choice, if I say I am inviting anyone, so my two choices are done. My two choices already done. Hence the remaining is out of 9 friends now. Out of 9 friends, how many choices I need to make? Because these two are already attending. I have already invited them. So remaining I need to pick out of 9, I need to pick 3 friends. Hence I am going to have C of 9, 3. And these are the two ways. Either I can do this or I can do this. Either I can invite both will attend, or both will not attend. Hence I am going to have sum rule over here. So this is going to be my solution if the restriction is such a way that one person attends if the other person attends, and if the person will not attend if the other person is not attending. So let me take the case 3. Where I am going to have two persons. So where will not attend together. Will not attend together. So now what I do? So now let me remove this restriction now. And so now I am going to have 11 persons. Out of this 11 persons, I am going to have person who, if the person 1 attends, person 2 will not attend, because they will not attend together. If the person 2 attends, person 1 will not attend. So now how many choices I have got? So now if I am going to invite P1, my one invite is done. I need to invite 4 more. Hence R is going to be 4. I have already invited 1. Hence the remaining, I have already invited 1. Hence the remaining is going to be how many? I need to invite 5. I need to invite 4 more people. I need to invite 4 because already invited P1. Hence P2 will not attend. If I invite P2, P1 will not attend. Hence I need to choose 4 out of how many? 9 remaining friends. Hence, n is going to be 9 in the first case. So, which will be C of 9 comma 4. Fine. This is the first case. In the second case, so this was the case for P1 will attend as P2 didn't attend. Where if I am going to invite P2, the similar case now. Fine. So either P1 for this solution. Now for P2, the same is going to be R equals 4 and N equals 9, because even I should think about this way, because if the P1 attends, P2 will not attend, I need to pick remaining 4 out of 5. This was solution. If I am going to invite P2, P1 will not attend, I need to pick 4 more out of remaining 9. Hence I am going to 9 comma 4. So now these are the two cases. Now there is one more case now. What if I am not inviting both? If I don't invite both, so this 2 will be out of my frame. Hence I need to pick how many inviters? That is 5 friends out of 9. Hence I am going to have C of 9 comma 5. So now if I am going to take the case 1, that is C of 9 comma 4 plus C of 9 comma 4 plus C of 9 comma 5. This is going to give me the solution for such scenarios with such restrictions, where I am going to have whether should I invite everyone or should I invite only 5, or should I while inviting this 5. So what are the conditions I should look into, whether the friends will attend together or whether they will not attend together. This is what I am going to look into such examples. And at this point, I hope you have got a good clarity of exactly how we need to think about permutation and how we should think about combination. Fine. So in the next session, I am going to take one more problem, and let me step into some other concepts which I was supposed to discuss in the module 2. Fine. So but before you meet up in the next session, so please give a try on this problem and think whether you should use permutation or combination to solve this particular problem. And thank you for this session.